All right, so this is a video on a quick video on how to mosaic multiple satellite images into a single data set. You usually do this if you download multiple Landsat scenes, or perhaps you have a bunch of planet imagery that you want to stitch together into a more coherent scene. So the first thing you need to do is add in the data that you're going to use as you've downloaded it. So Landsat data come the analytical data come in multiple bands that you're going to have to stack together. You can use the composite tool in ArcMap to accomplish this. In the case of mosaicing images to a new raster, the images I'm going to use here today already have been composited or put together. So I'm going to access some data that I was provided by the company Planet, and they have a bunch of CubeSats and other satellite assets, and they make commercial data that people can use for a variety of applications. And so I'm in particular in this data set, I have three 4-band images with relatively high spatial resolution that I'd like to combine into one data set so that I can run some analysis on that data. So I've added in all three of my data sets, and what's kind of neat about these is they have a very similar acquisition date, so they seem to stitch together as a coherent image, except for, with the exception of this one, there's some color differences here, but that doesn't really matter too much in analytical terms. It's just a visual thing. But the problem is if I want to run, say, a supervised classification or image segmentation or some tool like that, I would have to run it 3 times because these are 3 separate images. So what I'd like to do is put it together, since they were acquired on the same date by the same sensor. I'd like to stick them together in one image that I can run an analysis on. And basically, satellite data providers and air photo data providers chunk their data into multiple chunks to make it more efficient for downloading. So the best way to do this, since about ArcMap 10.3, is to use the Mosaic to new raster tool. It's a pretty easy tool to use. I'm going to open that up here. I'm going to search for it. And one thing to check out often is just to read the help before you actually use the tool so you understand what the options are. So as you can see, this tool merges raster datasets into a new dataset. And there's some qualifiers here that you should be aware of. The big one is probably not to use the GIF format because it only supports single band datasets, and most analytical datasets are multi-band. We're going to have to put in our output rasters and output folder location, a dataset name with one of the valid extensions here. So these are the valid extensions. I suggest you stick to TIFFs, IMG files, and perhaps Esri grids, but those are the three, probably IMG, which is an AirDAS Imagine file, or TIFFs that are going to be your best bet. And then the other parameters are optional. So we can have a coordinate system, we can have pixel types, cell size. Number of bands is not optional, but we should know that going in. The mosaic method and the mosaic color map mode. Now these last two are going to allow you to stitch together your data in a way that's more visually pleasing. So the the mosaic method is used to mosaic overlapping areas if you have them. This data set doesn't have any, so it's not a big deal. I'll just choose one. And then there is the, scroll down here, there's the color map mode. Now this is, what it basically does is it maps the color so that they're consistent across the images. So we can have we can use the first image put in there, the last image. We can make it match them all, which will be a little bit more processing time. And we can reject. Basically, only raster datasets that don't have a color map already will be mosaic. Most of the time, you want to match or just choose one. But be careful, because if you should understand how color map or color map matching or or changes might affect your analysis. Especially if you're doing spectral-based analysis where you need measurements of the spectral reflectance, you might want to be careful about these tools, or those color matching rather. So here's the tool itself. I'm going to put my 3 rasters in there. You can go through and click like this, but believe it or not, it can be faster if you have them all in one folder, just to add them through the add dialog box, because you can select multiple locations. I'll choose my output location. So I just need to select a folder. Now in this case it's a little annoying because my actual folder's got to go here, right? If I'm in the folder I want to select, it won't let me select it. It's a quirk of ArcMap and it's annoying, but it's unavoidable. Next I have to pick a raster name. In this case I'm going to call it forestwall.img. And then the other items here are optional for spatial reference. Since these have a spatial reference already in UTM, I'm not going to mess with that. I need to know my pixel type, and this is inherent in the data itself. 8-bit unsigned would be an older Landsat platform, like Landsat 5, the venerable satellite system. In this case, I want to look at my images, and I find that my pixel depth, pixel type, is 16-bit. And so I'm going to go back over to here. Oh, and while I'm in here, I might want to check to see how many bands I have. 4 bands, just to make sure. So my pixel type I'm going to want to set to match my input, which is a 16-bit unsigned data type, and I have 4 bands. Now I'll choose my Mosaic operator. In this case, I'm just going to make it mean, basically the average across any overlapping areas. And for my color match mode, I'm going to use match, just because I'm using this as a display of a phenomena that I've observed in the Brazilian Andes. Here's the output. You can see that instead of being, let me turn these up, instead of being 3 separate images, it is 1. And also the color maps match across all of them. So if you remember the bottom strip here, image, one of these ones anyway, had, you could tell that it was captured at a different time. And so this would be one image with the same properties, but as all 3 stuck together that you can use for analysis.